Hi everybody and welcome. Today in this video we're going to be talking about ratios and proportions. So your goal after watching this video will be able to understand conceptually but also solve problems that involve ratios and proportions. So to start off, I'm hungry. Think about cookies. I do love cookies so much. And they make me think of baking cookies. They make me think of a ratio. So on some nights, maybe I'm not super hungry and I'm not going to share with my wife, so I don't need to make all that many. Maybe I'm only going to make 6 cookies, for example. If I'm only going to make 6 cookies, I don't need to make a full recipe. So thinking about a proportion in that relationship, maybe it's half a cup of flour to a quarter cup of milk. If I'm only making 6, that's what I'll use. But maybe I'm making double that. You know, I need 12 cookies. My wife wants some. I want to bring some for lunch the next day. So if I'm going to double that, instead of half a cup of flour, now I'm going to need a full cup. And instead of a quarter cup of milk, I'm going to need half a cup of milk. So the idea here with these ratios and proportions is that if they get really big, we're still basically just using half as much milk as flour. So if we make 100 cups of flour, we would just, 100 cups of flour, then we'd just be using 50 cups of milk. So we can basically solve for scaling up these quantities when they're really big and when they're really small because they stay in the same rate. And if you don't keep them in the same rate, your cookies will not look the same. They'll look very, very different. So that's kind of the idea here, keeping things in a fixed relationship, and if we do that, we'll be in good shape. The obvious application to geometry is bigger and smaller shapes that are basically scale replicas of each other. So if you see a really small triangle and a really big triangle, and they both have exactly the same angles, again, their sides are in a constant ratio or proportion, and that's why we're focusing on this skill today. All right, so first let's start off by, let's just define ratio. So not something that happens to you if you get ratioed on Twitter, but this is actually the number of times one quantity contains, I can't spell, another. So for example, back to my cookies, for every 2 cookies for me, 1 cookie is eaten by my wife. So I'm having 2, she's having 1. That's how it works. So if I'm making 6 cookies, I'm gonna have 4, she's gonna have 2. Well, if I'm really hungry and it's Thanksgiving Day and, don't need to worry about anything on Thanksgiving, you just eat it all up, maybe I have 8 cookies. Well, if I do that, then I know that she has, it's a 2-to-1 ratio, so she has half as much as me, so she's going to eat 4. And that's the idea of these ratios. Again, it's a constant quantity here. Basically, I have twice as much as her, and that's how we can figure out questions like this. So let's take a look at our first example here. We have the total number of students participate in sports is 703, so 703, call them athletes. And the total number of students overall is 1850. And they want us to find this ratio to the nearest tenth. So this is actually a ratio here, 703 to 1850. But sometimes they want us to get it in a 1 to something ratio. So like a 2-to-1 ratio, what have you. Well, this isn't a 2-to-1 ratio exactly, but we can actually divide both sides by the same thing, just like we would in a normal equation, and we'll get 1 athlete. And if you punch this into your calculator, you're going to see that it's going to be 2.63. So 1 athlete to every 2.6 total students. And they said round it to the nearest tenth, so let's change this to just 2.6. Okay? And then now we can take this and we can apply it to some geometry. So that's the full answer for question number 1 right here. And I should make this more clear. We'll just leave that as 2.6 students to avoid confusion. So 1 athlete to every 2.6 students. So moving on, if we have triangles, and we have A, B, and C. Well, A to B to C will stay in the same ratio, regardless of how big or small the triangle is, if it's just scaled up or scaled down. So it'll look the same. Might be a little bit bigger, maybe it's really small, but it's the same triangle, same angles, just again, small versus big. So they're giving us a ratio for a triangle here. Long side is 13, intermediate side is 12, and our smallest side is 5. And they're telling us that the perimeter is 90 centimeters. Well, let's pause and let's see if that's what we just drew. perimeters, we add up all of the sides, 5, 12, and 13, that actually gets us 30. So we know that that's not the case. So our ratio of this triangle is 5 to 12 to 13 for our sides, and our perimeter is 30. Well, we're looking for what is our A, B, and C when our perimeter is 90. And we know that the ratio stays the same. They're in a constant quantity, constant proportion with each other. So let's see. So 30 times 3 gets us the 90 we're looking for. So if we multiply everything in this ratio by 3, we'll get 15, 36, 39. And let's add these up real quick. Let's make sure what we did just makes sense if it actually works. So it's 51, 39 does get us 90. So a triangle with these three sides has a perimeter of 90, and it's in the same proportional relationship. We're going to go over the mechanics for solving this on the next page, so don't stress if you didn't get that. The big idea here is that we're keeping our ratio constant, and that's how we're going to be solving some questions. Now it's asking us for the shortest side. Well, our shortest side is 15. So that's actually our answer. So the shortest side equals 15. So we're going to be solving some questions later on, keeping ratios and proportions the same, and it's going to allow us to get to a point where we can solve a question like this. So let's get into this. Proportions and ratios. So on the side here is a 3 to 5 ratio, and we're trying to see if we scale up this 3 to 5 ratio to something to 75, what is the something in the same constant quantity? Well, how do we solve these? We cross multiply. So 5 times x on one side, 3 times 75 on the other side. And then we just go through and solve it like we normally would. So multiply, divide, and we'll get that final answer of 45. So again, setting up some cross multiplication and then some division. So let's do that here for both of these next ones. Again, let's cross multiply and then divide and get an answer of x here and y here. See what they equal. And a final question to bring us back to what we were doing to start there in terms of solving word problems with these ratios and proportions is example number 4. So a boxcar has a length of 40 feet to a width of 9 feet. So that's its ratio of length to width. So a scale model is made and it has a length of 16, but we don't know the width. So you just put it in x. And that's the goal for today. Again, we can solve these ratios, we can set up ratios, we can solve the proportions, and we can get a final answer. So just like we were doing before, let's cross multiply. Let's set up that equation and then eventually work ourselves to an answer for x in inches because that is our width. All right, everybody, so I think 3 or 4 questions left here to solve. Make sure that we turn those in and get those completed. As always, any questions, feel free to let me know. And I will see you very soon in Teams. Thanks for